and welcome back to the tutorial series. We've got lots of stuff to cover, so let's get started. First things first, a couple of montages I added. So this additive one called hit interrupt. Bear in mind that it's additive with the reference pose, so it's going to play as an extra, as well as this death animation, which kinda like that. We're going to use these two on a different tutorial though. So let's get into the graph. I added a couple of extra parts. So this one right here, before we blend with the right hand slot, there are a couple of animation bugs in 4.11, and because it's the latest engine version and we can't update, we have to do several workarounds. So the first one is because this one can't stop playing, so we're just going to use this blueprint statement. So if we have no weapon equipped or a melee weapon equipped, we're going to use the melee cast. If not, we're just going to use the idle cast, which is supposed to be playing right here. And yeah, that's pretty much with animations. So let's get started. Today we're going to complete the bomb glove. As you can see, exactly like the game, and I can like shoot bombs and destroy everything. There we go, exactly. So yeah, never mind there. So let me start with the actual bomb first. Go down here to our mechanics, GUNZ, bomb glove. So got a couple of stuff here. So first things first, the bomb glove bomb. So got simple sphere scaled down to 0.3, set to block all, and simulation generates hit events. So we also got a projectile movement, and bear in mind, so this part right here, the initial velocity in local space, is not ticked. Yeah, bear that in mind, so it may not work otherwise. So on the begin play, we've got a boolean, so default value is false, set to true can detonate, and basically on the hit or overlap, we're just going to, do it once only, and with a delay actually. And then this whole part right here is copied straight from the bomb crate. So I also use, I also use the exact same settings, with the targets array. So you may want to go back and just take a look into that and paste that, because I'm not going to explain it a second time. So let's check our materials first. So got the decal material. As you can see, our target highlight decal actor, just a circle. Now you may notice that if we play, this is a square actually. So yeah, that's another engine bug that has not been fixed, but because it's the latest version, we can do nothing about it. So yeah, pretty much, so ignore that. And nope, I also got a particle system with beam data, source and target user set, only one projectile spawning with a constant rate of 0, so it only spawns one. Our particle material, pretty simple, just the blue, and initial color the same as the material. So let's check out what we do on our actual bomb glove. So I populated this class and now with a crap load of methods. So the first part, it would be to draw the trajectory. The third part, it would be to find where the trajectory ends and spawn the decal right there, as well as shoot. So if the event fire is pressed, we're at shoot, this is a new variable. So, and we got enough ammo. When we get the ammo, we shoot the bomb. We update the main UI with ammo. Then we play the throw montage. Set ready to shoot false. After 0.8 seconds, we set ready to shoot true. So let's check out the shoot bomb part first. I've got right here, so shoot bomb, we're just going to get the initial location. That's a function I made. Attach it to a transform, scale it to 0.3 because it's a small ball. Try to adjust location, but always spawn it, always. Then we're just going to get the initial velocity. This is another function I made, and then we're just going to set the velocity in local space from the projectile movement component, but because we untick the previous thing I told you about, it's going to be interpreted as actual in world space. So let's get into it. So The initial velocity, we're just going to get the direction of the character mesh. We are going to break it, add 90 to the z-axis with the yo, because the mesh is kind of offset when imported. You know, that's known if you've messed around with rotations from these mesh on the default template. You may should know that. Get forward vector, normalize it, scale that by 1000, add 200 to the z, so it's, you know, a lob movement, and then return the node. Same thing with the initial location. So just going to get the character mesh, do the same thing, break the rotator 90, then we're just going to get a vector, rotation x vector, you know, get a vector from the rotation. Then we're just going to ignore the z-axis, normalize, multiply by 80, so that's, you know, almost the width of the capsule collide, so we don't want our capsule to our bomb that we shoot to collide with the player. Then we're just going to add that to the actual location of the mesh, so I've got a nice offset. And then we just the z we ignored right here, we're just going to add 120, which is the actual half the height of the cylinder plus a little bit more, so it's like, you know, kind of in front of the hand. Now the big part on our event graph is the, where is it, the tick. So we're just going to cast a third person character if the current weapon is valid, and now if the current weapon is equipped is this one, so it's the bomb glove, we're going to draw a trajectory. If it's not, we're going to hide all the beam emitters that we use to draw the trajectory, also hide the decal, and yeah, clear all the beams as well. So you'll understand what this does by the end. Now on our begin play, with on the first part, you know, the standard things, then we just spawn our target highlight decal actor and grab its reference, set to hidden, and yeah, that's basically it. That's why we can reference it here. Now these beams are empty. If you take a look at the draw trajectory, which is where all the magic happens, don't freak out, so I'll explain. So first we grab all the beams, and if they're valid we destroy them and clear the array as well. So we've got a 5 local variables right here: initial velocity and location, self-explanatory, old position, old velocity, which are temporary, as well as final position, which is what we're going to use in order to spawn the decal. So let's get into it. So get initial velocity, set the initial velocity, also initialize that, get the location, same thing with these two. Now we're going to do a for loop with break from 0 to 200 with the 0.05 time step. So for each loop we're just going to get where the actual projectile is at. So if we expand this, it's actually high school math. Essentially it's this thing. So if this does not ring a bell, you might want to go back to high school and, you know, study a bit. So it's just physics, it's just an accelerated movement without losing some energy. So that way we calculate the position that the actual projectile is going to have based on this specific time. And if we go back here, we're just going to, you know, increase by 0.05, 200 times for that. And yeah, basically we're just going to then do a trace from the old position to the new position, and after that we're going to just set the old position and old velocity to be the new one because we're going to rerun it. Now this line trace by channel is each segment that we're going to use. So if there's a blocking hit and it's not an initial overlap, so it's not colliding initially with our character and something, you know, when it first spawns. And also, if the hit actor is not a bomb glove bomb, because we don't want to shoot a bomb and our graphics to freak out because that bomb is in the way. It's like a projectile that we ignore. So then, if it's true, so if there's a blocking hit, we're just going to set the final position, set the visibility of our decal to true, also set its world location to the impact point, and yeah, grab the impact point actually we should grab the normal from here, my bad. So grab the normal, grab rotation from that, set this rotation, and this wire goes all the back here to break, so we're just going to quit and keep on going on with our game. Now, if there's not a blocking tick, we want to spawn an actual beam, so I'm just going to spawn an emitter at the impact point at the trace start location. We are going to set its source to be the start, we're just going to set its target point to be the end, so you know, simple logic right there. Same thing with the final position up here. This impact point and trace end is actually the same place just because it's a hit event right now. So yeah, and then we're just going to add it to our beam so we can keep track of it. Now, while the player is playing the game, he's not going to see much of a difference. As you can see, it's just like normally, but if we go ahead and eject and like zoom in really close, you're going to see there's a gap right here. If you don't like that, you can go back here, decrease this number and increase this one relatively. So that's the trajectory drawing calculations. So you can find plenty of tutorials about this kind of physics all over YouTube. So thanks for watching. See you next time.